Good afternoon, students. In this video, describe about space complexity of algorithm. Already we study about time complexity of algorithm. The next concept is space complexity of algorithm. Okay, so actually the answer from this topic, space complexity. Okay, so normally how much space allocate for execute of an algorithm? Okay, how much space allocation? Okay, how much space allocation for execute an algorithm? Okay, let us see the definition. Whenever solution a problem is written, some memory is required to complete. Okay, so whatever it may be, so which action, the action may be storing, loading, writing, then manipulation, updation, increment, a lot of functions in a program is there. Okay, then so every solutions must allocate a particular space from memory. So the memory is a very basic concept used to do all function through this memory space. So memory must require to do all functions. So for any algorithm, memory may be used for the following concepts. Okay, so then how can allocate the space during execution of an algorithm? Okay, so what are the variables? The variables may be constant values or temporary values. Okay, constant values and temporary values. So we must use a lot of variables used in your program. So the program may be constant values, the temporary values, then assignment values, then dynamic values. A lot of variables are there. So all variables can hold a particular memory space. So the memory must allocate for that space. Okay, the next concept, program instruction. Program instructions means, for example, all lines in a program. Okay, lines in a program is called instruction. That means that may, for example, like yeah, in the a comma b comma c, like that. Okay, so the that is an instruction. Then how many space allocate for that instruction, because program instruction must process to do something. Okay, so then what is the reason to allocate space for this instruction? Because program means processing, so the memory must allocate space for execution. Then instructions containing more than one operands and operators are there. Then operator to do the action of operands, so the memory use the variables and operator. Okay, so variables means operands. Operands can hold a particular memory space, and the operator means to do action, that means execution. The executions also need to space for execution. Okay, so that is program instruction. After execution, execution means the whole program must executed to do some space, so the memory provide that space for execution purpose. Okay, so the memory, why we use memory based on the programming concept? So variables, then program instruction, execution. So these three terms used a particular memory space to do some actions. Okay, the next definition of space complexity is the amount of memory used by the algorithm. Okay, so space complexity is nothing but how much space allocating, otherwise how much space need to execute of an algorithm. Okay, so what are the contents of that algorithm? Input values to the algorithm, that means input values is also to do that means to need to some space from memory. Okay, so the amount of memory used by the algorithm to execute and produce the result. Okay, so why we use the space execute an algorithm? Okay, so then input values, then values may be different, so the all values are used to space. Then after calculation, then after storing the information, then after to complete the processing, we can get the result. So all functions need to do action based on the size of the memory. Okay, then one more thing, the auxiliary spaces also need to execution of an algorithm. Okay, auxiliary space means what? Auxiliary space is extra space or the temporary space used by the algorithm during its execution. So can you say about example of temporary space or execution space? That means that is a temporary space. Actually, what is that? Then during the execution of the program must otherwise the memory must allocate a particular space for what? Execution purpose. Then after to complete the execution, it is automatically deallocated. So the allocation space for execution is temporary. Okay, so then after to complete the process, then that is deallocated, that memory space used for another purpose. So this concept is already I explained in operating system. So the auxiliary space means extra space, otherwise temporary space during execution time. Okay, so space complexity means how much space used to during the execution time. So during execution time, then lot of memory space to do every actions. That means to assignment variables, then constant variables, then dynamic variables, then temporary space, then permanent space. Okay, so all things are use some space from memory. Okay, so that is space complexity. So commonly, how can define the space complexity? How much space needed to or required to execute of an algorithm is called space complexity. Okay, then how can calculate the space complexity? How can calculate? Then the formula used to calculate space complexity equal auxiliary space plus input space. Auxiliary space means extra space. Then plus input space means then how many variables or values input into the program. So that much of input space is added with the auxiliary space. Okay, so this general concept of space complexity of an algorithm. Okay, the next concept is memory usage while execution. Okay, so during execution, then how much memory space is using for the purpose of execution. Okay, so here different reasons are there for execution purpose. Then first one is instruction space, second one is environmental stack, then third one is data space. Okay, so this concept, that means a program containing more than one instructions are there. So each and every instructions are a different purpose. Then beginning of the program is assignment, then input. Okay, then middle of the portion means calculation, then storing, and so on. So then last section is then output section, that means display the result. Okay, so that is the concept. Okay, so instruction space means then the amount of memory used to save the compiled version of instruction. Okay, so a program contain more than one instructions are there. So the overall instructions about a program. Okay, then how much space? Then during compilation time, then how much space allocating for that instructions in a program. Okay, so that is a very important thing. Instruction space means during compilation, then after to develop the source code, then first process of execution of the program is called compilation. Then you have know about the concept of compilation. Then how much space allocating for compilation during execution of an instruction. So that is instruction space. Okay, then after environmental stack. Environmental means what? Then additional or extra space. Okay, so during the data structure stack. Okay, sometimes an algorithm may be called inside an algorithm. Okay, sometimes an algorithm. So this is a nested function or nested procedures or nested function calls. Okay, so that concept is given here. So sometimes an algorithm or functions. Okay, so a function call itself. That function is also call itself. That means what? Recursion process. Okay, so can you remember about the recursion process? That means recursion or repetition means a function or a calculations repeat again and again. So that concept is the recursion process. Okay, so environmental stack means then what is the space allocating for environmental stack? That means the nested function. So an algorithm or function called inside another function or algorithm. Okay, so that means the recursion process, that how much space allocate for that concept. Okay, in such situation, the current variables are pushed onto the system stack. Okay, so for example, a function a of is a function called another function b of is a function another a of is a function. Okay, so that function a of function is called another function b of. Okay, actually the location of b of function is from where? Inside the function a of. Okay, so a of is a function call itself function b of. Okay, so at that situation the variables of function a of is pushed onto the stack. Okay, so what are the variables keep in the function a of? So the function a of is again called the another function b of. So that function is inside the function a of. So at that situation the variables from the function a of is pushed onto the stack then to do the further execution. Okay, do you understand? That means here specify two functions are there. A of is a one function, then b of is another function. A of is a main function, then b of is another function. So that function inside the function a of. Okay, so suppose the function called b of function, the variables from a of is pushed onto the stack. Okay, for which purpose? Then to do the further execution, because the b of function is also use the same variable from the function a of. So that is the concept. Okay, so that is the environmental stack. Okay, so here how many processes are here? So many processes are there, because the function main function is first to activate the main function, then after to call its b of function. Suppose the b of function is called another function from itself, then once again they are activated. That means the variables from b of is also pushed onto the stack then to do the further execution. So that is the concept. So the all execution from nested function is called environmental stack. That means nested functions can carry some memory space. So that memory space is called environmental stack. Okay. So then third one is data space. Data space means amount of space used by the variables and constants. Okay. So the next variables, how much space allocating for variables and constants. So that is a data space. So normally our program can calculating only data. So then avoid the instruction space and environmental space, because instruction space means to execute the instruction. So that is a temporary. Environmental stack is also temporary. So both concepts are avoided just to focus on only data space, because a program can carry some variables and constants. So we must concentrate how much space allocating for variables and how much space for allocating for constants. Okay, so then how can calculate the space using the algorithm. Okay, so the instruction space, environmental stack and data space. Okay, so we can avoid instruction space and environmental stack. Okay, so both cases are we are using just temporarily during execution or compilation time. So we must focus data space only used to calculate the space complexity. Okay, the next concept is calculating the space complexity for each and every data types. Okay, so we need to know the value of memory used to different types of data type variables. Okay, so this is a concept we are already studying from UG classes, because in integer, then float, char, signed, unsigned integer, so then double, long double, so all of them to use some memory space. Okay, so that is a fixed size. Okay, so here is also to specify the table, then how much space allocating for different data types. Okay, so the data types is given here, then boolean, char, unsigned character, signed character, then integer, that means 8-bit. Okay, 8-bit integer. Okay, boolean means logical operators are yes or no, that is the concept. Then character, that means character, unsigned character and signed character. Character is a normal type, then unsigned character and signed character. And the integer can carry 8-bit information. The whole data types use 1 byte size in memory. Okay, then another one is integer is 16-bit integers, then short integer, unsigned integer, then word character. Okay, so these are the different data types can carry 2 bytes of information. Then after float then integer, 32-bit integers, then unsigned integer, long integer, then unsigned integer, so unsigned long, signed long and unsigned long. Okay, unsigned integer, then long, unsigned long, then after unsigned long. Okay, so these are the different data types then how much storage space, then 4 bytes of storage capacity, okay, storage bytes. Then next one is double, then integer 64 bits, then long double, then long, that means long decimal value, so it can carry 8 bytes of storage capacity. Okay, so these are the storage capacity used to calculating the space complexity for all types of data. Okay, then after to give example, what is that, is a give small instructions used in your programming concept. Then what is that, int z equal a b c, a plus b plus c. Okay, then after return z. Okay, then how many variables are using here, then a b c, then z. Okay, so these are the variables used this instruction. Then how much space allocating for these variables. Okay, so actually what is the total memory requirements, listen here, the formula is 4 into 4 plus 4 equal 20 bytes. Okay, 4 into 4, then 4, first 4 is represent 4, then how much storage space for using data types or variables. Okay, so here use 4 variables are there, all variables under integer type of data. So how much space for integer data type, so 4 bytes for integer data type. Then listen here, integer, then unsigned integer, then long, unsigned long. So the all types of data are carrying 4 bytes of information. So here all variables based on integer type data. So the first 4, so what is the formula, 4 into plus 4. Okay, 4 into plus 4. So the first 4 is represent for which type of data using the instruction. So that type of data can carrying particular storage capacity. So in this instruction all are integers, so integers can carrying 4 bytes of information. So we want to take 4, then into 4. The next one is 4 of 4, that means what, 4 of 4 means n. Okay, how many inputs used in your instruction, so that is the important thing. So n stands for how many inputs here, a plus b plus c. So these are the inputs, then after these inputs are added to get the sum is stored into z. So 3 input values, then after storing a value in a variable. So 4 variables are using here, so the commonly they are known as n. Okay, then how much variables are input into an instruction, so 4 into 4 16, then after plus 4, so we want to give 4 bytes of space, give the additional for the instruction, because the additional storage value is used to return the value from the instruction. Okay, so return of z, so that is a return concept. So how much space during the execution of an algorithm. Okay, so 4 into 4 plus 4, then you can get the answer is 20. So that is the calculation of space complexity of a simple instruction. So that is called constant space complexity. Okay, that is a constant space complexity. Okay, so here one thing, then first to understand what is the storage capacity of different data types using an instruction. Then after to calculate, then how many input values in your instruction, then after to use the formula, then substitute the value, then calculate the answer. Okay, so that is the space complexity of an algorithm. Okay, so that is the constant space complexity. Then another example listen here, then n is the length of array. Okay, n is the length of array, listen here. So int sum of int a of, so the array size is not specified here. Then after int n. Okay, so that is function declaration. Okay, sorry, function definition. Int sum of int a of comma int n. Okay, function definition, then it followed by function body. Suppose the function if containing for example, so do you remember that then this is function definition, because here is not specified the semicolon. Okay, if it is function declaration there is a semicolon, but here is not semicolon. So this is a function definition, because function definition just to set the data type, then after function name, then what are the parameters passing through the function, then next following the body of the function. This is following of the body of the function. Okay, so just I recall about that function definition. Okay, here to define the function definition, sum of int a of, okay, then int n, then next int x equals 0. Okay, so for I int I equals 0, I is less than I plus plus, then x equal x plus a of I. Okay, then return x. Okay, so these are the recursion process. Then how much space allocating for this instruction. Okay, then first of all we know that how many variables using in your instruction. So what are the instructions given here? X is one instruction, then n is another instruction, then I is another instruction. Then after to one more instruction, one more variable is there. Then what is that? A of is an array, because here not specified. Then during execution time the array must be using needed space only. Okay, so listen here. Then then how can calculate this? Then 4n plus 12. So that is the concept of total memory requirement for execution of an instruction. 4n, 4, then 4 means what? 4 is a type of data, then how much space allocating for that type of data. So in this example, so complete data, that means all variables are based on integer type data. So we must take the type of data can carry 4 bytes of storage capacity. Okay, so 4. Then after n means what? N is a how many inputs into the instruction during execution. Okay, how many values are there? Then 4. That means n, I, then x and a of. Okay, then 4. So 4 into 4, 16 plus 12. Okay, 12 means then to allocating for the return values of how many variables used to input purpose, how many values used to input value. That means x, n, I. So 3 values are input here. So each and every variables must allocate for a return value, that is 4 bytes. So x 4, n equal 4, then I equal 4. So these 3 variables must return the value. So x equal 4 plus n equal 4 plus I equal 4. So 4 plus 4 plus 4, you get 12. So that is the answer. So how many variables you use it into instruction, then increasing. So increasing linearly, then that means increase the space complexity. Okay, when then repetition process or array elements, then that is used to more space during the execution of the program. Okay, or algorithm. So that is a concept. So this is a formula. First 4n plus 12, that means 4 is the type of data can hold how much storage capacity. So here is using integer. So integer can carry 4 bytes of storage capacity. Then after n is represent for how many variables used in your instruction, then plus 12. 12 means then a return value of each and every variables only for the input section. Okay, then after added to get a constant value. So that is used in your formula. Then after calculate the space complexity of given algorithm. Okay, so this is a linear space complexity because the space is increased one by one. Okay, so that is linear space complexity. Okay, so these are the constant space complexity and linear space complexity. Then what is space complexity? But our concentration only to save the time and save the space and save the job. So we must focus only less space, very small space used to during the execution of an algorithm. So that is a better to calculate the space complexity. That is a very important thing. Okay, so I think you can understand this concept. Okay, thank you.